Greetings, my little triglets. We are ready to move onward and upward. Section 6.5. We are going to be solving trig equations. So basically, they're just equations with trig in them, sines and cosines. So, for example, let's think algebra here just for a second. Let's say I have 3x squared equals 9x, and I ask you to solve for x. You may not divide by x, because if you do that, you'll lose one of your x answers. It divides away. So instead, we have to get everything on one side. So bring the 9x over and then factor out something. So 3x squared would be x minus 3. And then, because this whole thing is equal to 0, either this is 0 or this is 0 for that to be true. So to solve it, we set each part equal to 0. And so the answers are x is 3 and x is 0. So the process is going to be similar, but instead of having x here, we'll have sine of x. And you'll have to take it one step farther. So let's throw in some trig and see what happens here. One way to solve these is by factoring. So we need to factor. So if I have something like sine 2x equals negative cosine x, and I want to solve this. What we need to do is we need to bring the cosine over to the other side, sine 2x plus cosine x, and see if anything can be factored. Well, there's nothing in common here now, but this is a double angle formula. And the double angle formula has another form of 2 sine x cosine x. Hopefully you have those memorized. And then adding the other cosine x. Now they do have something in common, so I can factor that out front. And I'm left with 2 sine x plus 1. Don't forget, when you divide a cosine by the cosine, by factoring it out, you're actually leaving a 1 there. So now we set each part equal to 0. Cosine x equals 0, and 2 sine x plus 1 equals 0. Well, cosine x equals 0. Let's think about our circle. If cosine is 0, that means I'm not going right or left, so it would be here and here for the answers. So the answers are going to be pi over 2 and 3 pi over 2. So those are two of the answers. Now we go over here and solve this. So I have 2 sine x equals negative 1. Divide by 2 sine x equals negative 1/2. Now that's another one on our circle that we know. Negative 1/2 for the y value for sine would be here. So 7 pi over 6 and 11 pi over 6. So those are two more answers. So these four answers are the values that if I put them in here and here, this comes out true. Those are the only four answers on one trip around the circle. So it's not true all the time, but it is true for those four answers. All right, so factoring is one way to solve these. The next way to solve it is to express the terms using only one trig function. Okay, so get everything in terms of tangent, or get everything in terms of sine, or something like that. So we are going to start with sine of x plus cosine of x equals 1. Now that almost looks like the Pythagorean identity, but it's not, because it doesn't have the squares. But what we are going to do is try to get it to the Pythagorean identity. We are going to square both sides. Now remember, when you square both sides, or scare both sides, you have to look for the phantom answer. Okay, because we're scaring both sides, we look for the phantom. So let's do this. Now remember, I said square both sides. Before we do that, I want to isolate either the sine or the cosine. I'm going to choose the cosine, or the sine. So I'm going to bring the cosine to the other side. Now I'm going to scare both sides. So I get sine squared x equals, now this you have to FOIL, so 1 minus 2 cosine x plus cosine squared. Now, what that does is it gives us the ability to change this into its Pythagorean identity of 1 minus cosine squared. And now everything is in terms of cosine, so it makes it easier to solve. So I'm going to move everything over. I'm going to bring all these over to the other side. So the ones will cancel out. The negative cosine squared and another negative cosine squared is negative 2 cosine squared. And then this I'm going to bring over and actually put it in the front and make it positive 2 cosine x. So, and that's all equal to 0 because I brought everything over. Now, what they have in common is a 2 and a cosine. So I'm going to bring that out front. 2 cosine out front. That leaves me with 1 minus cosine in the parentheses. And if you're not sure what I just did, just think of redistributing this, and you will get back the original expression there. Okay, at this point, we need to set each part equal to 0. So let's do that over here. I'm going to change color to isolate it a little bit. So 2 cosine x equals 0, and 1 minus cosine x equals 0. So divide by 2. So cosine x equals 0. Now we just did that one. We said it was pi over 2 and 3 pi over 2. Over here, if I bring the cosine over, I get 1 equals cosine. Now where does cosine equal 1? This is 1, 0, so it happens at 0. Now we have to test for the phantom. So what we do is we go back up here and put those values in. Now I'm going to go to the next page. So we got to remember that these pi over 2, 3 pi over 2, and 0. Pi over 2, 3 pi over 2, and 0. And our equation is sine x plus cosine x equals 1. All right, so let's put in pi over 2. So I have sine of pi over 2 plus cosine of pi over 2 equals 1. Think of your circle. Pi over 2 is here. Sine is 1. Cosine is 0. So that one works. So that's a good one. So the next one, let's change color here. So sine of 3 pi over 2 plus cosine of 3 pi over 2 equals 1. 3 pi over 2 is down here. Sine is negative 1. Cosine is 0. That one does not work. So we cross that one out. And we'll do one more. Sine of 0 plus cosine of 0 equals 1. Here's 0 here. Sine is 0. Cosine is 1. So that one checks out as well. So those are your only two answers for that one. Okay. Now, we're going to run into some little quirky things. Something like this, sine of 3x equals 1. Now we're used to just sine of x equals 1. So basically what this is saying is that you need to do 3 trips around the circle to get all the answers. If that's a 2, then it would be 2 trips around. The easiest way to do these is to think of it as the problem without the 3, and then we come back and we adjust it for the 3. So we are going to think of just sine of x equals 1. Now that happens, sine of x equals 1 right here at pi over 2. So that's the answer. Now that's, if I'm going around the circle, the first time I hit there. Now if I keep going around and I hit it again, I'm going to be at 5 pi over 2. And if I go around another time, I'm going to be at 9 pi over 2. So this is 1 time around, this is 2 times around, and this is 3 times around the circle. So what we've done is find where sine of x equals 1 3 times around the circle, but we need it to be 3x. So basically, we're putting a 3 in here, so we're multiplying x by 3, so all of these, to keep it balanced, we have to divide by 3, which means multiply the denominator. So my true answers are pi over 6, 5 pi over 6, and 9 pi over 6, which is really 3 pi over 2. Okay, now I know that's a little bit confusing, but because the 3 is multiplying by the x, I have to divide the x's by 3 to keep it balanced and keep it working. So if I try to put a pi over 2 in right here, it's not going to work. But if I put a pi over 6 in, 3 times pi over 6 is pi over 2. So essentially we're putting in pi over 2, but the 3's balance out. So these are the right answers. Okay, so basically what you do is you ignore the 3, and you go 3 times around the circle, and then you divide all answers by 3. That's the process. And if that were a 2x, these would all change to 2's. So it just depends on what number is there. Okay, one more idea. Sometimes you're going to find answers to the nearest hundredth of a radian. These are problems that don't come out to things on the circle. So let's try one. 6 sine x minus 1 equals 3 sine x plus 1. Now you have to think algebra here a little bit. Instead of sine x, let's say I had 6a minus 1 equals 3a plus 1. Same problem, except I have a instead of sine x. Treat it like you would a problem like that. So I'm going to subtract 3 sine x from both sides. And I'm also going to add 1 to both sides. So I have 3 sine x equals 2. Divide by 3. So sine x equals 2/3. 2/3 is not on our circle. So this is where you have to figure this out. You have to do the inverse sine. Okay, so inverse sine of 2/3. And that should get you 0.73, I believe. Let me double check that. Now you have to be in radians. So inverse sine of that is 0.73, yes. Okay, now remember, because we're trying to find an angle, it's like the alien angle. So 0.73 is about here, because this is 3.14, this is 1.57, 0.73 is about there. And it's sine. So I need to find the mirror image over here. So I'm going to take 3.14 minus 0.73 to get that one. So I get negative, or not negative, but just 2.41. So that's the other answer. So those are my two answers for that one. Okay, so the big thing is treat it like algebra, but when you get to the end, you actually have to figure out the values of sine and cosine. Don't divide by sine or cosine, because you lose answers, or any other trig function. Okay, so don't do that. And you're still looking for two answers a lot of the time. And sometimes you're going to be in radians, sometimes you're going to be in degrees. And also, if you have like this sine of 3x, you may not divide that by 3. The 3 has to be out front, and then those can cancel. You may not cancel this. This is part of the angle. That x is your angle, so don't divide there. Okay, I think that's it for Trig section 6.5. Just don't forget, don't ever, ever forget, Trig is love.